Hi, it's Mike Power with Silver Range, and this is a look at our East Goldfield project. First, quick word from our lawyers. East Goldfield is located about 10 kilometers from the town of Goldfield. It's in Nye County and is accessible by county roads with a 4x4, and there's an extensive network of roads on the property. At the moment, the property consists of 110 federal load claims, and it abuts and is contiguous with Centerra's Goldfield project. This part of the Goldfield district has a long history. The Tom Keane Mine, discovered in the early 1900s, has minor undocumented production and underground development on 4 levels. There are numerous small exploration workings on the property. In terms of modern exploration, the project has been basically continuously explored since it was discovered. But in more recent years, Cameco explored on the property, followed by Metallic Ventures, Chaparral Gold, and finally Silver Range picked it up in 2018. Here's a look at those historic workings. We've documented about 100 in the project area, the most advanced of which is the Tom Keane Mine. We don't have a lot of information about the early days of Tom Keane, but it's clear that by 1931, development on 4 levels had been completed down to about 500 feet, and there'd been extensive drifting. A 2-compartment shaft had been constructed. It's an incline shaft, and some sampling done at that time suggests that there was some decent gold values at depth in the mine. Mineralization on the property and in the Goldfield district in general is high sulfidation in character, and in fact, it was at Goldfield where high sulfidation deposits were first recognized and defined. They occur beneath volcanic complexes, edifices, typically calc-alkalic, so andesites and dacites. At depth, highly volatile fluids ascending from the source magma interact with the country rocks and deposit these very rich gold deposits. They typically form at the base of the water table and immediately above, where ascending vapors, these are fluorine, chlorine, hydrogen sulfide, so forth, mix with meteoric water to form extremely acid solutions. And these acid solutions follow paths of permeability to the surface, and they completely erode the country rock through which they travel. They basically remove all of the minerals except for quartz, and what they leave is a spongy mass of vuggy quartz. Surrounding it is an envelope of quartz alunite, that's residual quartz, and the alunite's formed when all of the feldspars in the rock are completely eaten up and destroyed. And surrounding that is a clay alteration zone, typically of kaolinite, although it can grade out into illite. The mineralization occurs in 2 stages. During an initial stage of ground preparation, these highly volatile HF, HCl, H2S, whatnot, hit the water table, they generate the acids, they leach out this vuggy quartz, and they prepare a site for subsequent mineralization, which occurs in a second stage. And this is lower, less acidic mineralization, around pH of 5, and is carrying metals, commonly gold along with copper, not a lot of silver, some bismuth, tellurium, and these solutions mix with meteoric water, and that leads to mineral deposition in those favorable vuggy quartz environment and in the rocks immediately surrounding them. An interesting feature about these deposits is they're often formed at depth, so they need a lot of erosion to be exposed. There's an example from the Andes where only a very small amount of the deposit was exposed by erosion, and it took a lot of drilling to actually define it at depth. So you find just the tail of the tip of the tail of the tiger sometimes, and then you have to drill off at depth to find the fully preserved deposit. East Goldfield is located in the prolific Walker Lane. That's home to many famous and large rich deposits. We've basically got the Comstock in the north. We've got Tonopah, of course, the Goldfield deposit, and now the emerging Silicon Merlin discoveries down near Beatty, where they've drilled off over 16 million ounces of gold. So the Walker Lane is a great place to look for rich gold deposits, and the East Goldfield project is adjacent to an Oligocene volcanic complex, calc-alkaline complex. Moving into the property area, let's have a look at the regional geology. The property outline shown on the right in gray, and you can see the town of Goldfield on the left. Before we get started, I just want to draw your attention to this circular feature here that's evident in the topography. It'll show up again in the geology. The oldest rocks in the district are Alaskite and older Paleozoic palmetto formation cherts. They're formed in the western part of the property. They're in an uplifted block, and these are a basement to the whole district. Overlying these is an early latite, which was erupted about 30 million years ago, that partially covers these rocks. But then the main event occurred about 20 million years ago, 22 million years ago, when the Goldfield dacite and Milltown andesite were erupted and intruded. The Milltown andesite is the older of the two. The dacite intrudes it, and it covers much of the district and hosts the bulk of the mineralization that you find in the Goldfield district. In addition, off on the property is this hydrothermal breccia. It was originally mapped as a landslide. And it's an unusual formation. More about that later. Now, all of these three formations, the Milltown andesite, Goldfield dacite, and the hydrothermal breccia, host the mineralization in the Goldfield district. There are a sequence of cover rocks above that, volcanics and sediments, and we need not concern ourselves anymore with them. Here's a structure. Now, that circular feature I showed you in the topography is reflected in the geologic structure. And what the circular structures you see up here are, they appear to be part of a ring dike pattern around an intrusive center here, perhaps a failed intrusion. And in addition, there's a handle, if you will, to this circular frying pan, and that runs through the East Goldfield project here. There's an alteration envelope which surrounds the mineralized rocks. It's shown here in red. And finally, the known gold deposits in the camp are around this alteration zone and ring structure. The Goldfield main district is shown here. That's where 4.2 million ounces at about 17 grams were extracted historically, and there's a small resource left here. This is the Gemfield deposit, and this is the McMahon Ridge deposit here. These three deposits form the mineralized areas in the Goldfield project of Centerra, where they announced in February of 2025 a resource of about 709,000 ounces at 0.71 grams. Alteration in the Goldfield district is quite intense. This is a plot of aster data that has been processed to image alunite. And as you can see, we have the characteristic circular pattern of the district together with the handle to the frying pan, so to speak. Silver Range's East Goldfield project is here, centered on perhaps the most intense alunite mineralization in the district, this side of Preble here. You can ignore this feature here. This is actually the tailings from the combination mill. The Goldfield main district is right here, and McMahon Ridge is up here. So there's very intense alunite alteration in the East Goldfield project area, which is highly encouraging if you're on the hunt for high sulfidation gold deposits. Here's the geology in the property area. This is based largely on the work of Roger Ashley in 1974, supplemented by some work we've done since. You can see that there's a strong structural grain in here, west-northwest to east-southeast, and it's centered on this hydrothermal breccia unit here, which is also where you have the most intense alunite alteration in the district. The hydrothermal breccia unit is fascinating. It contains a mixture of both Milltown andesite and Goldfield dacite clasts, so it's clearly younger than both those two units. It may be locally fault bounded, although it's very difficult to map or conclusively identify faults in this intensely altered area. It was originally mapped as a landslide deposit because it was very large, but in looking at it more closely, we believe it's actually a hydrothermal breccia based on the shape and composition of the clast, the intense alteration, and the setting. The hydrothermal breccia is also the axis along which we find most of the anomalous geochemical responses, particularly in gold. In the Goldfield district, gold mineralization is associated with vuggy quartz in what the old miners used to call ledges, an example of which is one of this here in the top left. These are largely formed of spongy quartz. They're very resistant, so they stick up like ribs. You see them all throughout the Goldfield district. Not every one of them is mineralized. Marginal to the quartz ledges, you often find quartz alunite, which looks like this. It too can be resistant because there's still quite a lot of quartz in it, but the pinky tan alunite and jarosite is your indicator that you're into that. And finally, the gold mineralization occurs in the ledges, but it's very cryptic. It is very difficult to determine what rocks will run and won't in this environment, and it makes sampling quite challenging. We're looking here at ATAC discovery of a zone in the north where they found 4 grams over 8 meters. And if you look at these rocks, they look like pretty much all the other rocks you find in the district. So the gold mineralization is very cryptic, and a lot of surface sampling is required to detect where you may have a gold-bearing ledge. Let's have a look at alteration on the property. Our partner ATAC Resources flew a drone hypospectral survey over most of the property, and these are their results. Now, porphyroite is a mineral that occurs at the very base of the high sulfidation environment, in the region that's transitional between the high sulfidation environment and the underlying porphyry environment. There's a little bit of porphyroite on the property. It's just on the west end here. Dickite is a clay mineral that forms in an acidic, high temperature environment, so it's often associated with high sulfidation mineralization. And you can see that the dickite that was detected in the survey is largely along a central axis here, which is coincident with the regional aster alteration anomaly. And that anomaly was defined by alunite, and you can see here the alunite response in purple. It follows this central axis that was evident in the aster anomaly. Flanking it are areas of gray, which are kaolinite. And this is what you'd expect to see in a high sulfidation environment where kaolinite flanks quartz alunite in the center of a system. Some of this material has been shed down the arroyos. You can ignore this material, this response down here, and most of this up here. It's interesting to note that the Tom Keane Mine is actually off the axis of the main alteration anomaly. This is illite, and you'll note that it is even further outboard than the kaolinite, and that's what you'd expect in a high sulfidation environment. And finally, there's a little bit of opaline quartz, but it's not central to the story here. Well, let's get down to brass tacks. Here's a look at gold in rock samples, and this is results from both Silver Range sampling and ATAC Resources work. ATAC found a couple of new gold showings on the property, notably here, where they found 8 meters at about 4 grams in surface, and this area down here. I should say, though, that sampling for gold in this property is extremely difficult. The rocks are intensely hydrothermally altered, and it's very difficult to discriminate between rocks which might run and rocks which are completely barren. Their ATAC's success seemed to stem from doing these close-spaced traverses along ridges and spurs, and that might be a way forward to finding new mineralization on the property. We've run soil geochemical surveys on the property. Here's a look at the results. Not surprisingly, the best gold values are actually along the axis of the alunite anomaly and the hydrothermal breccia over here, but there's some gold responses that are off axis, notably down here and over in the area of the Tom Keane Mine. We have some historic drill data available for the project, and we were able to acquire this through the generous assistance of the Nevada Bureau of Mines and Geology, and we'd like to thank them for that. Our drill database has 66 drill holes for which we have callers. Not all of these drill holes have results, unfortunately. In addition, we have results from 10 other holes, but no callers. So our drill database at the moment is a bit of a mixed bag. You can see that much of the historic activity was concentrated down here in the area of the Tom Keane Mine. Here's a summary of results. Of the intersections we have, 93, the top 10 are shown on the left, and there's a few good ones. But I should point out that most of the intersections in our drill database are a gram or less. However, it's notable that some of the intersected intervals were quite thick. So we have a lot of low-grade mineralization and a few high-grade hits within it. With this drill data in hand, we've been able to define a target for exploration on the property. That's the area shown in green here. Intercepts within this region are consistently hitting gold, and we were able to use that data to define a target we believe could be drilled to develop a starter resource, which could then be expanded by exploration elsewhere on the property. This target for exploration was developed by Matt Dumala of Archer Cathro USA, and here are the drill holes he used in this target. The first thing he noted was that there's a cutoff of gold mineralization. Basically, material above to the north here is not gold bearing, or there's very low gold values. All of the gold intersections occur south of this linear. It may be a fault. It was mapped as a fault by the USGS, but we see no evidence of it in outcrop. That's not surprising. This area is so intensely altered, it's very difficult to pick out any structure. So it might be a fault, might be an impermeable barrier. Nonetheless, it appears to dip off to the north, and it explains why a number of the more recent drill holes drilled in this area missed intersecting any gold mineralization. They're basically drilled into the hanging wall and missed the mineralized footwall, which is down here. And in this area, Matt defined the following intersections here. Each of these points is a piercement, and the fascinating thing about this is if you look at the elevations of these piercements shown beside them, they basically occur along a flat or gently dipping surface, or actually several of them. We believe that what this reflects is the control and mineralization by the paleo water table. So you're basically seeing the mineralization developing where it hit the base of the paleo water table, and that's where the gold was dropping out. Matt defined the following domains. You can see that they range in thickness from a few meters to up to 30 meters, and the gold grades vary in the different domains. Putting it all together, we've defined a target for exploration of between 2.2 and 6.6 million tons, with grades that could be between 0.34 and 0.62 grams per ton gold. And this translates into between 55,000 and 72,000 ounces of gold possible with this target. And I should stress again, this is not a resource, it's just a target for exploration. But nonetheless, it shows the way forward, and there is a clear path towards drilling off a resource in this area based on the work he's done. Here are some perspective views of the target model, which of course is shown in red here, and you can see the drill holes. The Tom Keane Mine shown in each of the plots. And the target horizon is at a depth of about 130 to 170 meters where the model has been defined. We're looking off to the northwest here. Here's a view to the north, and here's a view to the northeast. So, as I've said before, we believe this flatline geometry reflects water table control on the base of mineralization, and we think it also renders this target a pretty easy one to drill off here. You won't have to drill long deep holes and scratch your head about looking for stuff deeper. We think you could follow this horizon on strike and perhaps develop a resource both here and adjacent to it. But wait, there's more. This is not the end of the story. There are other gold occurrences both on surface and in drill results which could be followed up. If a starter resource is drilled off at Tom Keane, these other occurrences might point the way to considerable resource expansion. Northwest of the Tom Keane Mine, ATAC found an outcrop that ran 8 meters at 4 grams. There were no historic workings in the area of this outcrop. Now, they tried to test it by drilling 2 holes underneath it, and they missed. They hit nothing. Now, after looking at the results near the Tom Keane Mine, I think we see why. In our new drill database, the 2 best drill intercepts in the entire database occur west of the Tom Keane Mine. And in addition, in this same area, ATAC found a 2-gram rock sample, which is quite good result for this property. So here's just a couple of examples of places that could be followed up. In addition, I think applying ATAC's close-spaced sampling protocol along ridges and spurs might work very well in many of the other unexplored areas of this property. So there's lots of work left to do here. So why East Goldfield? Well, we're next to 3 deposits with 5 million ounces of gold, either mined or in resources. They're in the same rocks, same style of mineralization, and if anything, we have more intense alteration. We have a well-defined target for exploration of 50 to 70,000 ounces of gold, which could be drilled off to form a starter resource. And there's considerable room for expansion. Finally, we've figured out that the gold is occurring at about the same elevation through much of the property, which makes drilling it off very easy. We think East Goldfield is a great target, and somebody who wants to roll up their sleeves and drill off a resource should have a good look at it. Thanks.